Let's take a look at next example. Remember that we defined a function to be a relation with specific conditions. Now here we have an example. We're going to define a relation, relation T from the real line, bolded R, to real line, note that I'm using bolded R, as follows. We're going to say that for ordered pairs in the Cartesian product between R and R, X is in relation with Y over T if and only if Y is equal to 2 times absolute value of X. Question says, is T a function? Is inverse of T a function? Okay. Just going back to algebra, we're going to graph these two and analyze the behavior. Okay, so Y is equal to 2 times absolute value of X. Let us graph it. Remember that going back to algebra, X and Y, if X is equal to 0, your Y is equal to 0. If X is equal to 1, Y is 2. If X is equal to -1, the absolute value of -1 is 1. So 2 times 1 just give you 2. Remember the graph, x-axis, and then you have the y-axis. It behaves like this. 1 and 2, -1 and 2, 0 and 0. So this is your relation T. This is my relation T, which is obviously a function. It passes the vertical line test, and it is a function. So it's a function. Very good. Now, what about the inverse of T? We're going to analyze the inverse of T. Recall that the inverse of T is defined as all of those Y and X values such that X is in relation with Y, such that Y is 2 absolute value of X. Okay, so how do I visualize this? I can take some random values, random points. I already have some of these. Some points in this relation are as follow. For example, I have 2 and 1. I have 0, 0. I have 2 and -1, and so on. You can continue this process. But take a look. I have 2 and 1. I have 2 and -1. These 2 points doesn't satisfy the definition of a function. For specific X value, you have 2 different Y values, which is not a function. For X equals to 2, we have 2 different Y values. So what's the meaning of that? It means that it's not a function. Inverse T, not a function. T is a function, but its inverse is not a function. So if a relation is a function, it doesn't necessarily mean that the inverse of that relation represents a function. We need to analyze each one of them separately.